Hi, this is Kent Brown, Senior Product Manager at Microsoft. Today I'd like to introduce the Windows Azure queue capabilities. I hope this will help you understand how the Service Bus queues are implemented and demonstrate how they could be useful in your applications. Queues are a vital part of your messaging solution. They provide a flexible buffer that enables you to decouple your application and the services it uses. Three key benefits that make queues so powerful are: first, load leveling, so you don't have to build an infrastructure to support your peak traffic. Let's say that you have a web application that takes orders and sends order requests to the fulfillment system. However, most of these orders come between noon and 2 p.m. and again from 5 to 7 p.m., at which time the fulfillment systems are overloaded and prone to crashing. By placing order requests on a queue, they can be stored up during peak times and processed by the fulfillment system as it gets to them. Ultimately, load leveling saves you money, as you don't need to pay for the excess capacity to handle peak traffic, which then goes underutilized the rest of the time. Secondly, loose coupling between sender and consumer. Your messages sent to the queue are durable and will reach their targets even if the message consumer is offline for a period. Suppose your fulfillment system is occasionally offline for maintenance. You need to ensure that any orders placed during this downtime aren't lost for good. With queues, orders can be stored up until the fulfillment system is online again. This provides a lot of resilience for your overall system in the event of failures of individual components or services. Finally, load balancing. With queues, consumers pull data from the queue, unlike HTTP load balancing, where messages are pushed to the consumer. If you set up multiple consumers for a queue, the effect is a natural load balancing where each consumer processes messages as fast as it can. In our order taking scenario, let's say there are two fulfillment servers, but one happens to be twice as powerful as the other. You don't want your application to wait on the slower machine, nor do you want to have to build complex logic to poll each consumer and try to determine the optimal load it should take. With queues with multiple consumers, the consumer with the most resources performs more jobs simply because it finishes faster and comes back for another message to process. This efficient load balancing helps you make the best use of the resources available at any time. So let's discuss some of the broad benefits of the Service Bus and queues in particular. You don't need to provision and manage a complex messaging infrastructure. Since the Service Bus is a cloud service, we take care of all that for you. And as a service-based solution, it provides a cost-effective pay-as-you-go model. Queues help you scale your applications. The load leveling and load balancing effects we discussed earlier allow your system to handle higher loads with less capacity. As a Windows Azure service, the Service Bus can scale to meet the growing demands of your application without you needing to purchase and configure new hardware. Finally, you can interact with the queue using multiple communication protocols. .NET developers who are used to message-oriented programming patterns with technologies like MSMQ, MQ-Series, or JMS can use the .NET API. This is a very familiar API which exposes the richness of the queue for a .NET application. Developers who are more service-oriented and used to programming with WCF can communicate with queues easily using the appropriate bindings. You can also use REST over HTTP for web-oriented applications or from platforms other than .NET. So that's a brief introduction to the features and benefits of the Service Bus queues. Please visit windowsazure.com where you can find the latest information and additional resources. This includes a series of short demos showing how you can set up the Service Bus for your business application. Many thanks for your time.